So let's go and understand basic loops in Python. For those of you who know what a loop is, for those of you who have seen something like a while loop in C, C++, or Java, you'll remember and you'll see that the while loop in Python is very similar to the while loop in C, C++, Java, except for some small syntactical changes. Intuitively or logically, it's the same thing. For those of you who don't know what a while loop is, imagine if you have a bunch of code. Let's assume these 4 lines of code that you want to run over and over again, which means you want to run them and again you want to go up here, again run them, again go up here and run. If you want to run something over and over again or iteratively as it's called, then we use loops. Very simple loop is the for loop. Sorry, is the while loop. We'll also see the for loop. So let's go and see some examples to understand why for loops are important. So the syntax is very simple. So we have the while. While is a keyword in Python, and we have the text expression with a colon, just like our if. This is something unique to Python. This column. So whenever the text expression is true, the body of the while loop will be executed, and all of it is indented. Just to remind you, indentation. Try and do 4 spaces in indentation. That's a good programming habit. Okay. So, but remember, this body will only run when the text expression is true. Let's see an example so that there is also a flowchart here for those of you who like to see flowcharts. But I always prefer examples typically. So let's go through a simple example. Let's assume I have a list. I'll execute this step by step. Okay. Suppose I have a list LST which has 5 elements. This is element 0, element 1, 2, 3, and 4. I want to find the product of all of these numbers. How do I do it? So I'll declare a variable called product and assign it a value of 1, and I'll create a variable index with a value of 0. If to multiply this, let's think about the logic. What if I multiply product with 10, right? I'll get some value. I'll get 10 here. The 10 if I multiply with 20, that which if I multiply with 30, and so on and so forth. So if I have to write it more mathematically, can I write it like this? Can I write it like 1 multiplied by, list of 0 multiplied by list of 1 multiplied by list of 2, so on so forth till list of 4, right? This will give me the product of all the numbers, right? You might ask, why are you putting 1 here? Okay, even if you don't put 1 here, it's okay. So, but intuitively, this is what you're doing. But what we'll do is we'll multiply it with 1, because multiplying it with 1 doesn't change the value. So here you're doing the same operation of multiplication multiple times, right? You're repeating that operation, or you're iterating and doing the same operation over and over. So let's see how to write some simple code for that. Okay, so let's look at it. So first, your interpreter went here, it went here, it went here, then it comes here. Now, what is the value of index? Value of index is 0. What is the length of list? 5, because there are 5 elements here. Is 0 less than 5? Yes. So this is called the test condition, right? This is true. So as soon as it's true, it will go inside the while loop. So what's there inside the while loop? So since this is true, it will say product multiplied equal to list of index. What is index? Index is 0. What is list of 0? List of 0 is the 0th element in the list, which is 10. So product multiplied equal to 10, which means now what happens? Now your product becomes 10, because star equal to is nothing but product equals to product into 10, right? Now what happens? Now this line also will be executed. Index plus equals to 1, which means what will happen to index now? Index right now is 0. So index will become 1. Now as soon as index has become 1, now, so your interpreter actually went inside, it ran this. Now this is over. Immediately it will go back and evaluate, it will go back to the first line. Okay, this is what iteration is. Okay, now what happens? What is the value of index? 1. Is 1 less than 5? Because that's a condition we have to check, right? This is your test condition, right? Yes, it is less. So it will go inside. Now product multiplied equal to list index. What is the value of index now? Index is 1. So list of index is 20. So now product has a value of 10. So 10 star equal to 20. What will that be? Which will make product equals to 10 into 20, which is 200. Now index will now increase by 1. It's called incrementing. Okay, this is called incrementing or increasing it by 1. So now index will become 2. It will keep, now again your loop will go back to the first line. It will keep doing it till, so let's assume my index becomes 5 because I'm increasing my index with every iteration, right? Imagine index becomes 5 at one point, right? Then what happens? This condition fails. When will that fail? When your product has multiplied with all the numbers till 4, till 50. That's what I meant. Till list 4, right? Then what happens is, because this test condition has failed, right? It will not go inside. It will not go inside anymore. It will directly come and try to execute this next line. This next line is empty. So it will come here and execute this. So it will print the value of the product. Okay, so let's just execute it and see what happens. So this is how loops work in most programming languages. Okay, I'm just trying to get this to, okay, so now I have it. Okay, your product is this. Suppose if I just change it just to show you that I didn't cook it up. Okay, the numbers are changing. Okay, and this is the product of 10, 20, 30, 40, 60, right? So this is how a while loop looks like, and this is what while loop does internally in most programming languages, and but this is how it does it in Python for sure, as we saw. Now, unlike other languages, there is an interesting part here. Now, what happens if I have a while loop? Just like if else, I can also put an else for while. What happens is whenever this condition fails, this else part will run. This else block will run whenever this condition fails, right? So for example, in this condition, in this, what I'm doing here is I'm just printing the numbers in my list called numbers. Okay, so let's try to execute it first. Okay, let's see if it runs properly. Okay, so if I just say, I'm just changing it slightly. So what it's doing, it's basically saying, okay, if you look at the code, of course, with time, you'll get used to looking at loops and understanding it immediately. So index basically tells me which index I should be at, right? Now, my index less than length, my length is 5 again, just like the previous case, right? Index is 0, print the number. So it will print 1, 2, 3, 4, 5. At some point, index will become 5 because you're incrementing index here, right? Index will become 5. Now, when it becomes 5, what happens is there will be no more items left, right? Because this condition has failed. 5 is not less than equal to 5 at some point. Okay, after it has print all the numbers, right? Then what it does is interesting. Then it goes and runs whatever is there in the else block before going out of it. Okay, there is one catch that often happens. A lot of times people forget to do this part. One of the biggest reasons. If you forget it, what happens? If you forget it, this is a very interesting thing. Suppose if I forget to print this, if I forget this line, then I'll remove it and show it to you, by the way, programmatically. Then your index is never getting increased, is never getting incremented, right? Which means this loop will keep running, this loop will keep running, this loop will keep running. Such a loop is called an infinite loop. So if you have a program with infinite loop, it will be impossible for you to get out of it. So it will never stop executing. So let's see an example. Let's run this by removing this line. I'm removing this line here. Okay, just to show you, saved it. When I run it, it's continuously running. See this star symbol here. It's running, it's printing. So this star symbol here shows that the program is still running. Okay, of course, we need to kill it, of course, now. So what I'll just do is I'll interrupt. Okay, which means I'm going to say stop this. Okay, see how many values it has printed. It has printed like, because it's continuously doing that. It's printed all these values. So always remember, never ever forget to increment whatever is being iterated on. So index is called the iteration variable because you're iterating on that. You're using it to check, and if you don't increment it, you're in big trouble. If you forget this line, this will keep running infinite times till the time you block it or you stop it explicitly. Okay. Okay. Having said that, let's go and see a more real worldish example. So imagine if I want to write a simple program to check whether a given number is prime or not. Okay. So let's see how to do it. It's very, very simple and straightforward. Okay. First, let's run this code so that we know what's happening. Okay. Let me just quickly run this. Let's enter a number. Let's assume I enter 19. Okay, it says 19 is a prime number here, right? Let me just highlight that. Okay, it says 19 is a prime number, which is good. So what if I enter a different value? Okay, let me rerun it again. If I enter, let's say 16. Now it tells me that 16 is not a prime number, and it's telling me all the values that 16 is divisible by. 16 is divisible by 2, 4, 8. Just as a quick recap, for those of you who forgot what a prime number is a number which is divisible by itself and 1 and no other number, right? So how do we check it? We basically divide a given number by every number between 2 to n minus 1, given the number is n, right? So let's see. So here I'm just saying, okay, this is your standard input output, right? I just say enter a number, and whatever number is entered here, I'm converting it into integer, because real values being prime is ridiculous. It's only integers which can be prime or not, right? So my number is the number that I've input. My num variable has the number that I've physically input, as you saw a while ago. I'm creating a Boolean variable called is divisible. This value will turn to true whenever, suppose my number is 19. What I'll do here is I'll check whether 2 can divide it, whether 3 can divide it, whether 4 can divide it, 5 can divide it, so on and so forth, till 18 can divide it. If any of these numbers can divide it, of course, 19 will always be divisible by 1 and itself. If any other number can divide 19, so 19 is inside my num, right? Okay, so if any of these numbers can divide it, I'll change is divisible to true. Now at the end, I'll say if it is, okay, let's look at the code, right? So before we go and see the loop, let's see what it is. So at the end, I'm saying if is divisible, which means if is divisible is true, then say it's not a prime number. If is divisible is false, print that it's a prime number. Okay, so intuitively, what am I doing? If you have number is 19, if your num is 19, I'm taking all the values from 2, so on and so forth, 17, 18. And if any of these numbers can divide it, can divide 19 and have a remainder which is 0, then 19 is divisible by all these numbers, right? So here what we have to do, we have to divide 19 by each of these numbers. As soon as you have to do something repeatedly, you have to think, okay, I have to use loops, right? So I've given a variable I as 2, which means my I is here now. My I has a value of 2. And while I is less than num, my num is 19, right? Which means my I, this loop will run. And here I'm saying I equals to I plus 1 at the end of this loop. This whole block is my loop, right? If you think about it. So by looking at these two, you can easily say that this loop will run from I equals to 2. Since I'm incrementing it, next time what happens? I becomes 3. Next time I becomes 4, so on and so forth till 18. As soon as I becomes 19, this condition will fail, right? So by just looking at the condition and how the variable is incremented, you can say what the loop will run through. It will run from I equals to 2, right? I equals to 3, I equals to 4, so on and so forth, I equals to 17 and I equals to 18. Okay, now what are we doing inside this loop? So we understood the iteration part of it, right? Where is it starting? We know it's starting at 2. We know when it will end. We know what all numbers in between will be iterated through. Now what I'm saying here is if num percentile I, percentage is a symbol which I think we discussed earlier, which gives us the reminder when number is divided by I. So for example, for 19 percentile 2 is when I divide 19 by 2, what is the remainder? The remainder is 1, because 2 9s are 18 and the remainder is 1. So this gives us the remainder. If the remainder is 0, okay, if the remainder is 0, so for example, if my number is 18 percentile 2 is 0, because 2 9s are exactly 18 and the remainder is 0. So this is, you can think of it as a remainder operator, a numerical remainder. Okay, when you divide number with I or num with I. Now when that is 0, you know that your num is divisible by I, which means as soon as you see it, you say, oh yes, you change the is divisible by true and you print that, okay, so and so number is divisible by my I. As soon as you have it true, even if one number other than 1 and the number itself, if any other number can divide it, you say it's not a prime. Exactly, that's what is happening. So it will keep running it. At the end of it, if my is divisible is true, right? Then if it is true, which means there was some number between between 2 and n minus 1 or num minus 1 that could divide it, and hence I say it's not a prime number. Otherwise, okay, if no number could divide it, I'll say it's a prime number. Very simple code. I strongly recommend you folks go through this in more detail and understand what's happening and try this. I mean, since all these IPython notebooks are at your disposal, I strongly recommend you play with it, right? So we'll see other types of loops and other constructs within loops in the next videos.